Law of multiple proportions given by John Dalton. When two elements, for example hydrogen and oxygen, they combine to form two compounds, that is H2O and H2O2, such that here second element is say oxygen and first element is hydrogen. We have two compounds H2O and H2O2. Here the first element hydrogen, its mass is fixed, F for first, F for fixed mass, that is hydrogen, and the second element oxygen, S for second, that is it combines in a simple ratio by mass. So, what is that? Oxygen. When two elements combine to form two compounds such that second element combines in a simple ratio by mass with fixed weight of first element. For example, in H2O and H2O2, H2 mass is fixed. In the first case H2O, O mass is 16 and in H2O2 mass of oxygen is 32 and the ratio is 16:32, that is 1:2. So, second element oxygen combines in a simple ratio 1:2 ratio with fixed mass of, that is hydrogen, first element. So, two elements, two compounds, first element hydrogen mass is fixed and second element oxygen combines in 1:2 ratio, which is a simple ratio. Likewise, two elements sulfur and oxygen, they combine SO2 and SO3 they give, and here in both cases sulfur first element mass is fixed and second element oxygen, its combining ratio is 2:3. So, when two elements combine to form two compounds, second element combines in a simple ratio by mass with fixed weight of first element, known as law of multiple proportions given by Dalton. Law of reciprocal proportions or equivalent proportions given by Richter. Yeah, here three elements, for example carbon, hydrogen and oxygen. Carbon can combine with hydrogen forming methane. Carbon can combine with oxygen forming carbon dioxide. So, here in both cases CH4 and CO2, carbon mass is fixed and here hydrogen H4, its atomic weight is 1. So, H4 means 4 units of hydrogen by mass. O atomic weight 16, 16 2s are 32, 32 units of oxygen by mass, and their combined ratio 4:32 is nothing but 1:8. That means, let us take this hydrogen and oxygen as second and third elements and carbon as first element. Combining ratio of second and third elements with fixed weight of first element carbon is 1:8. So, hydrogen and oxygen combining in 1:8 ratio by mass with fixed weight of first element. Then second and third elements, that is hydrogen and oxygen, they combine between themselves and forming water. Here in water, mass of hydrogen H2 2 units and O, its mass 16 units. So, combined ratio between themselves 2:16, that is 1:8. So, here when three elements combine to form three compounds such that the combining ratio of second and third elements with the fixed weight of first element is 1:8 and combining ratio of hydrogen and oxygen which results in the formation of water between themselves is 1:8. Both are one and the same. Combining with carbon in 1:8 ratio by mass of hydrogen and oxygen, combining ratio between themselves by mass 1:8 ratio, both are same. Instead of H2O, if you take H2O2, then here we have hydrogen mass is 2 and oxygen mass is 32 and combining ratio 1:16 between themselves, which is a simple multiple relation to 1:8. It means when three elements combine to form three compounds such that second and third elements combine with fixed weight of first element, this combining ratio and combining ratio of second and third elements between themselves is same or bears a simple multiple relation by mass. Law of combining volumes given by Gay-Lussac. It is called Gay-Lussac law of combining volumes. Gaseous reactants combine in a simple ratio by volume. If the product also gases, Gay-Lussac law of combining volumes can be extended to gaseous products. For example, here one volume of hydrogen gas combines with one volume of chlorine gas, forming two volumes of HCl gas. Hence, the combining ratio by volumes, one volume of hydrogen combines with one volume of chlorine and gives two volumes of HCl. Hence, the combining ratio 1:1:2 by volume. Example, 11 liters of hydrogen gas is mixed with 12 liters of chlorine gas under similar conditions. What is the volume of HCl gas formed? Here, one volume of hydrogen gas combines with one volume of chlorine gas, forming two volumes of HCl gas. 11 liters of hydrogen is mixed with 12 liters of chlorine. So, this is what we call before the reaction. And in the reaction, one volume of hydrogen, that is 1 liter of hydrogen with 1 liter of chlorine forms 2 liters of HCl. By having 11 liters of hydrogen, this 11 liters of hydrogen can combine only with 11 liters of chlorine, that is ratio is 1:1. So, let us multiply with 11, 11 ones are 11, 11 ones are 11 and 11 twos are 22. That means 11 liters of hydrogen gas combines with 11 liters of chlorine gas, forming 22 liters of HCl gas. After the reaction, out of 11 liters of hydrogen, total 11 liters of hydrogen is consumed minus. So, left out is 0 liters of hydrogen. Out of 12 liters of chlorine, 11 liters of chlorine gas consumed and left out is 12 minus 11, 1 liter of chlorine is left out. And here originally HCl is 0 liters before the reaction and it is produced how much? 22 liters of HCl. So, in this reaction, based on the amounts, H2 as it is totally consumed, left out amount is 0, hence it is correctly called limiting agent. And out of 12 liters of chlorine, 11 liters of chlorine consumed, 1 liter of chlorine is left out. It is called excess agent, remaining left out.